So as I mentioned, if you can't be on Zoom, that's okay. We don't meet ever on campus because this class is called MDC Live. And even if I wanted to meet, there is no classroom assigned to our class because it has to be done synchronously on Zoom, which means that you need to be at the same time logged into Zoom. But to help you, those cases when you cannot be at the same time, I record lectures. So if you miss it, it's not a big deal. You can watch a recording later or over the weekend. Because I know it's a summertime, lots of people like to be on vacation, and I think it's impressive that you want to take the class during the summer, and that's why I record all my lectures, and that's how we're going to do this. So no meeting on campus for any classes that called MDC Live. There are no meetings on campus. When you say, is that a online? Well, online is different. Online means we don't even have Zoom meetings at all. So when we have a classes run by online department, it's different than our campus. It's special online campus. Then they don't even have any Zoom meetings either. Well, when I teach those classes, I still run Zoom in order to keep my students up to date so they don't get very far behind. But in this class, we only do the class meetings that happen to be in a Zoom format. Before we had this special other program, Blackboard, but now the college changed it to Zoom. So I think Zoom is more flexible. So anyways, the textbook is free that I found online for you. Let me show you again how you can get it. I just went to the search engine. In my case, it's Google. So I use Sylvan, name of the author, pre-calculus, and then PDF. That's important because without PDF, you'll get tons of offers to buy this textbook. And why should you buy it if it's available for free? So pre-calculus, the first choice I click on, and that's how the textbook appears. And I recommended you last time to upload it to your device, and I hope that you all have by now a convenient working laptop or a tablet that college checks out for free for the semester time period. And if you decide to continue with this same campus or even with different with MDC, one of the campuses in the fall, they'll probably let you keep this little tablet another semester. So as long as you are our student, when you say, are they gonna contact me and tell to return it? Well, if you register for fall semester classes, and right now registration is going, so I recommend you to register for more classes in the fall because they get filled up and they get closed, and the class that you want to take sometimes may be already filled, and the only choice you will end up with is like some Friday night class or some other times that nobody wants to take. So that's why the advice is check out the course schedule and think about registering to the fall semester classes. And that way, when you register, you can just contact the library who gave you this tablet and just tell them that you are gonna continue with this tablet in the fall semester. So there, I don't think be a problem with that. So you can keep it if you like it.
Professor, do you teach calculus?
Not this coming semester.
Okay.
No, maybe later, maybe we'll see how it works because they have lots of, but there are lots of classes in the calculus that you can take pretty much in any campus. Because if you're taking this class in the so-called live format, there'll be other campuses such as Kendall or various others, Norse, they provide those also classes in online format. You just need to dig into this a little bit deeper so you can always find them, because in our campus and West Campus, there are not many sections of calculus, and I think they're all being in person unless it's a business calculus. So I know what your preference is, but if you're looking for the live class, then you can always try to find it for in the other campus. And I could also teach calculus, but not in the fall, maybe in the spring, and in a live format, if you decide to take it in such a way. But I need to have at least 15 students. So if there be 15 students saying, Alex, we want to take this class with you in a live format, I can always go to my chair and show the list of students, and we can always schedule it in the live format. So that wouldn't be a problem. So I do teach calculus, but usually it's in the in-person setting in our campus, because we usually have 2 sections of calculus 1 and then probably 2 sections of calculus 2 and 1 section of calculus 3. So yeah, I do teach all of those classes, but they don't provide them in live unless students request. So if there be a list of students that want to take it, then I can always submit this to the chair and we can always open the section. So anyways, that's for fall semester. Oh, for the spring semester. So at the end of this semester, we can talk about this if you still be interested. And now we're going to go to the little bit of a review. I told you that there is a bunch of sections, actually chapters at the end of this textbook that we have to cover, 14, 13, 12, 11, and we'll be selective about 10 because this polar stuff is not what we do because it's trigonometry. So I know some students did not take trigonometry and went directly to the pre-calculus, which is fine. But some of the chapters of what we need to cover utilize trigonometry. So I'll just be skipping those sections. So no worry, I'm not going to expect you to know something that you did not learn. So what I want to do is take a look at so-called circles story. It's a section 1.4 today. Just to start, it's from beginning of this textbook, and it utilizes something very interesting and probably very, very familiar to you. It's called Pythagorean theorem. Pythagorean theorem that deals with right triangles, 90 degrees angle called right triangle. And if there are 2 sides around this 90 degrees, or they call them as legs of triangle, if you add squares of those sides, then it'd be equal to the square of the longest side, which is called hypotenuse. So how is this applicable to the case of circle? Well, turns out that we produce circle by fixing its center, and then we take the so-called segment or radius of a circle and rotate it around the center all the way around, and that way we produce our circle. So we get the graph of this by using so-called center, and center is usually called with a pair H and K. That's what we also like to use in college algebra for various points, HK. So that's like vertex for parabolas, if you remember. If not, it's fine. So, and then any point on this circle will be pair XY. So I give special name HK because it's a center. And this point is being produced by that rotation. And what's so remarkable is the fact that the distance from center to any point on the circle is always going to be the same, and this distance is called as a radius of circle. In other words, I can consider this right triangle, and instead of hypotenuse C, I'm going to use letter R, which is radius. And then I can also try to produce coordinates for my points and somehow put them as A and B, the measurements. So notice that if I had this A and B here with coordinates XY, right? There's a point coordinates XY. So there'll be X here and there'll be Y there. I just made another picture because it's getting too messy to put everything on just one picture. And then the other point will be done with coordinates H for X and then K for Y. Then I can see that A, the length, A will be the distance in between H and X. So it'll be X minus H. Let's see, really? Well, let's say if H is equal to 1 and X is equal to 3, then distance in between 1 and 3 will be 2. So it's 3 minus 1. So that's what they do. From the right end, subtract left end. So this is for the one say, Alex, looks like this is 0, 0. Well, it's for convenience I put the axes. I have to put them somewhere, but they don't have to have circle with center 0, 0. That'd be too ideal. And analogously for the other length, which is going to be along the y-axis, which is called B, then we need to go from y to the other coordinate, which is our y coordinate k, right? So y minus k will be the analogously found, just like we did with the x value, so that would be b value. So I'm going to go ahead and replace. Instead of a, then I'm going to put my difference h minus k. I'm producing the formula here. I'm not planning to, x minus h, get really deeply into algebra, but I was just trying to give you a little bit of a flavor of calculus, how they do it in it. And then b is y minus k, so that's our other measurement instead of b squared. And that's how we're going to produce the formula for the equation of circle with respect to the radius, but we don't want to have a squared, we'll get just r. So in order to get rid of this square, I extract the square root on both sides, and we get a kind of unpleasant looking formula here. And that's the one that we actually can see in the textbook that appears right there. So that's equation for the radius, and that's actually the description of entire circle. So that's people say it's a circle with radius r, and the center of the circle, because it doesn't have to be 0, 0, so the center is paired with coordinates h and k, center. I know this is not very pleasant looking formula, but if you're gonna see it again and again, well, hopefully eventually you'll start to get used to it. But looks like this is the formula that they came up with, and they actually like to have r squared, so they don't have the square root on the left side, so there'll be just r squared rather than to have letter r. So today's goal is to do a couple of problems to start getting used to this formula, because this is something we're going to use a little later in the actually chapter 10. That's what we're heading for. And today I just want to look at section 1.4. And at the end of this section, there are always exercises. Remember, skill building problems, those are ones that I will be looking at all the time when we are in class. So skill building group of exercises. So concept and vocabulary, are you prepared? Those things I usually skip, but well, you can always try if you like some of those. After we do skill building, I'm sure you will be able to do these problems as well as if you want to. So let me try one. Let's say exercise number 11 here. This is section 1.4. It says we have a radius equal to 2, and we have a circle with a center at 0.00. That's a center. And all I have to do is plug in the formula that we just produced for the center HK00. So let me write this formula once again. X minus H squared plus Y minus K squared is equal to square root of radius. So when you have a formula, all you need is just plug numbers in. So instead of R, I put 2. Instead of H and K, I put 0. So I'll get X minus 0 squared plus Y minus 0, because K is also 0 squared. And of course, this could be simplified. So we get a 4 on the right side, and then X squared plus Y squared is on the left side. So that's the equation of circle. And even if you want to graph it, you can circle, make a picture. Center is the origin, 0, 0. And then R is equal to 2 radius. So I can produce the circle around this origin somehow like that. So what's remarkable is the distance from any point on the circle to this center, to the radius, is always equal to 2, just like that. So, and that's why it's here, and it's all given by the Pythagorean theorem. That's the idea. But we're not gonna really use this Pythagorean theorem when we do problems, because it's like a proof of it, and every time we don't want to go through this pain. We just want to do it once, produce formula, and then we can just take advantage of this formula in every exercise. And that's how we always do this in mathematics. So let me try one more exercise just to show you that it doesn't really matter. All problems are pretty much same here. So if I try number 20 here. So it's analogous question. They tell you that radius is equal to 1/2. Well, you say, can I use 0.5? Yeah, you can use 0.5. Same thing. And I know that, so I won't mind if you use decimals. I know some people like it because they put this in a calculator. Well, you can do whatever you like, as long as it's correct. I never pick on my students, say, oh, you use the decimals rather than fractions. So it's your choice. But I'll just use those fractions because they're my little friends. So what I do is take this equation, just like in the previous problem, and now I'm gonna replace H with a 0, K with -1/2. So instead of H, I put 0, instead of K, -1/2. So on the left side of this equation, now we have X minus 0 squared plus, again in the parentheses, 1Y minus -1/2 squared. Okay, and this is going to be equal to a square of radius, which is 1/2. Okay, so I put 1/2. I need to use right. 1/2 squared. So this is equation of circle with a radius 1/2 and center at point 0 and -1/2. How about that? So you get a quarter. 1/2 times 1/2 is 1/4. And it's again x squared, but now y is going to be with a plus sign, right? So we say y plus 1/2 squared. That's it. So just plug in numbers in. So if you have the radius and if you have the center, you just plug it in. And of course, they ask you for the backward procedure to give you like an exercise number, say 21 equation and determine what is the center and what is the radius. So they give you the equation and they want you to go backwards. So they give you the actual end of the story, and they want you to go back and discover what's the squared on the right side, right? That's radius. That's how we find it. So radius is 2 because it's squared. And what do we subtract from x and from y? Well, it's Alex, we subtract nothing. Well, then it means that we subtract zeros. So from x and from y, I subtract zeros then, and that will give me coordinates of center, and they be 0 for x because I subtract 0 here, as well as 0 for y. So I was able to return back to the, I guess, beginning like we had in the previous exercises. Well, it's not always obvious because we need to sometimes do a little bit of algebraic tricks to get there. So first of all, I can do problem 23. That's another recommended exercise that has 2 multiplied by x minus 3 and then squared and then plus 2 multiplied by y squared, right? And then you need to get 8 on the other side. So how can you find the center and the radius? And the answer is we need to look at what our goal is. Notice our goal is to have nothing in front of parentheses with squares. So this numbers 2 and number 2 here is what I need to take away. And we take them away by dividing by this number 2, left side and the right side of my equation. So I'm going to get just a 4 here, and then x minus 3 squared without any coefficients because they canceled, right? And then same with the next term. I could put plus, instead of y squared, I put y minus 0. We already know we need to subtract something. And that's it. That enabled me to determine that center will be 3 and 0, and the radius will be whatever is squared. Looks like it's 2. So looks like a little bit of algebra will help us. But now here comes the most important part of this section, and that's actually the reason why I do this entire section before we move on to the end of the textbook where we have to start. See, we're starting at the end here. So let me try exercise 27. That one that needs to do so-called completing of squares procedure. So here we have x squared, and then next to it, I'll put plus 4x. So I'm going to rearrange. I'm going to prepare for something real big, for doing a little bit of algebraic trick on this. Then I'm going to put y's together, y squared and minus 4y's next to it. And then on the other side, I still have, oh, I'm going to take that minus 1 and bring it over to the other side. So I'm going to put it plus 1. So that's how I'm going to start. Because my goal is here. My goal is to produce a clear equation with a radius on the other side, on the right side. So I bring this 1 on the right side. And now I need to have parentheses squared with x's. And it turns out I must take the number 4 because what really bothers me is having this x term. So I need to take 4 and divide it by 2. So the rule says divided by 2, the 4, and squared. So 2 squared is what I'm going to add, which is actually 4, right? 2 squared is 4. And that 4 I'm going to subtract. So if I add and subtract 4, nothing is going to change. But these first 3 terms I can write as the so-called perfect square. I'll be able to put x on the first position and the last number 2 on the last position with a plus sign. See, really? Is that really going to work? Well, what you can do is check it out. X plus 2 squared is x plus 2 multiplied by x plus 2, right? And when you be multiplying the x terms, you will get x squared. When you multiply in last terms 2 and a 2, you're going to get 2 squared. Right? And then the products of inside and outside. Did you ever see the so-called FOIL method? 2x and the outside is 2x. So it'll be 2x and 2x, and that's what gives me 4x. So it's like twice 2x. And that's why when I have the term here with x, I divide it by 2 because when you FOIL, it's multiplied. So you don't have to go through these detailed ideas. All you need is just to take half of 4 and put this in the parentheses. And then I'll copy whatever remains, -4, just the way it is. Because that doesn't participate. And I will do exact same thing with the other part. I will look at the y part and do the same thing again. I'll divide it by 2. See, all you have to do is just divide it by 2, and that's going to give you a 2 that I squared. In other words, I add 4 and again subtract 4. When you add and subtract the same number, +4 -4, it means nothing. But similarly to what I had before, I'm going to have parentheses with first term y, last term 2 squared, but the sign will be negative. It's negative because the minus is here. So we again completed that square. And again, you can check if you want to, but it'll be the same like in the previous procedure. And then this -4 is also going to stay, and equals to 1 is also going to stay. So the point is now I have what I needed. Now I have x plus 2 squared, and then also y minus 2 squared. So I'm producing what is supposed to be done to be able to see the center of this circle. And of course, on the other side, I'm going to need to take all the numbers over to the other side. So I'm going to be adding 4 here and here, and another 4. So I'll be adding another 4, and another 4. So we got 4 and 4, 8, and 1 is 9. So what is the center? Well, looks like now I need to change the sign. What do I subtract? Because that's like x minus -2. The reason is we always have to have a minus, right? So we subtract negative. That's why we change sign in the parentheses, people say. And analogously for the other piece, it's a 2 that I have with a plus. Again, I change sign minus to the plus. And then radius, we call it as r, will be 3, because you can say it's 3 squared instead of 9. And this is different. And I know that people don't like it. It is annoying to complete squares. Usually when I teach college algebra, I do that, but I know that there are some shortcuts that people like, and they never learn how to complete the square. So it's time to learn now. Because without this, you won't be able to do problems in chapter 10. That's why I like, yes.
Professor, I have a question. Where did you get for the equation? Where did you get minus the 2 minus 4s?
Where I get 2 minus 4.
Like you have x plus 2 squared minus 4, and then you have plus y minus
What
2
the-
squared
hold
minus
on.
4.
I'm very slow. Let's do it slower. So I get x plus 2 minus 4. You're talking about 2 squared minus 4.
Yeah, like how did you get, like where did the minus 4 come from?
Well, if
And
I
the
add
2
4, I
squared.
must subtract 4. So that's why I don't change the equation. So if I have equation x is equal to 2, I can add 4 to it. But in order not to change the equation, I must also subtract 4. So that way, equations stay the same. In other words, you add, and then you have to subtract. Because if you add and don't subtract, equation changes. So I add 4, then I subtract 4. Where did I do? That's a cheap trick. So if you don't do this trick, you're not going to be able to produce what you need. And that's something we need to get used to in order to be able to complete the square. So you always add and subtract the same thing. That's how expression stays the same. Because if you added 4, well, it's not the same. You need to subtract 4. And again, you do this to complete the square, to produce this parentheses squared, because that's what our goal is, to have something in the parentheses squared. So yeah, that's not obvious. This is probably the most tedious procedure that you see. In fact, I want to tell you it's the most tedious procedure for this entire class. That's why, well, we need to get used to it. And I'm not going to hurry you with that. I'm not going to give you a quiz today. I'm going to do another problem instead. So I hope by Friday you will try to do the same thing again. Remember homework, I asked you to do the same things, same problems. And I hope that way you will start to get used to it. Because I do know this is not obvious. When I saw it first time in my life, I was also not feeling very pleasant about all that. But, well, let's do it again. And then maybe next time we'll do it again. And then we'll get to the chapter 10 and we'll do it again and again and again. So there'll be a few sections that do the same thing. So no worries, you will little by little get used to it. And that's my goal, to make sure we got used to this. So let me try problem 31. I'll do one more. I don't want to totally confuse it. I'll just do one more and then I'll let you think about it. In exercise 31, we have 2x squared. Let me copy it the way it is. Plus 2 times y squared. And then we also have minus 12x and plus 8y. 12x and plus 8y. And there's a number which is 24 subtracted and equals to 0. Okay. So my goal whenever I work on the equations to keep it simple, not to have all these factors of 2 with it. So I'm gonna go ahead and divide everything by 2. And the key reason why is because we need to have clean x squared and y squared, just like in the previous exercise where we had just x squared and y squared. So when I do this, I will get what we need to start. So it'd be x squared and then plus 12 over 2 will be actually minus 6x. Should be careful. And put x's together with each other. And then leave a little room and have plus y squared after. And then with y's, 8 over 2 is 4. And then also we still have minus 12 here, right? Minus 12. I'm going to bring away to the other side. It'd be positive 12. So numbers assumption we're going to work on later. And now I'm going to do exact same thing we just worked on the previous exercise. And the same thing means to add and subtract the same exact numbers. So I take a half of what's with x, which is 6. If I divide it by 2, I get 3, right? I divide by 2, I get 3. squared. So it's 9, and I minus 9. You see, you just wondered, minus 2 squared and then plus. So it was actually plus 2 squared and then minus 4. 2 squared plus 4 and then minus 4. So now the same thing I do here. Plus 9, minus 9. Analogously for the other piece. Half of what's with y, because this y term bothers me. Just like here, x term bothered. X squared is fine, but x term needs not to be present. So I'm here with y. Half of 4, which is 2. So I add 2 squared, always squared, and then subtract the same number, whatever it is. 2 squared, okay, plus 4, minus 4. So now we can put these x's and y's together. And that's the point of this. So I put parentheses. First term is x, because it's squared. And last term is 3. 3 squared. And you see minus here. Okay, so we'll put also minus. And again, if you want to check, if you want to multiply x minus 3 with itself, because it's squared, you will get exactly these first 3 terms. And that's the point of this trick. It is trick. I know it is not obvious. It is a little trick, but that trick enables us to get what we need. And that's the idea. So same with these 3. I have parentheses, squared, because that's what we need. First term and the last term will give us those 2 pieces. One is y, the other is 2. And everything is positive, so I put a plus. And copy the rest, which is minus 4 and equals sign 12. And notice we got what we need. We have coordinates of our center. I just need to change signs, but let me first bring these numbers away. Got overexcited. So plus 9. So I kill minus 9, but I have to also add 9 on the other side. I say, Alex, we were here adding and subtracting. Yeah, you could add and subtract to the same side of equation, or you could have that subtraction simply bring over to the right, so there'd be no more minus 9, so you get a plus 9 on the other side. So change sign when you bring the number to the other side. So these pieces disappear. We don't need them on the left. We need them on the right. So I add 9 and 4 is 13 and 12. 25. Oh, that's one of the favorites. 5 times 5 is 25, or 5 squared, right? So now I can see what center is going to be. So we just have clear, perfect squares. People say when it's squared in the parentheses, it's a perfect square. So center will be coming from 3. First parentheses, say change sign, get 3. Second parentheses, say change sign of 2, get minus 2. And the radius, it is 5 squared. So if you wish, you can make a picture of it, but you don't have to. So I would recommend you to redo one of these exercises. Let's say maybe I can redo both. Well, you can do both, because as I said, we're going to move on Friday to the chapter 10, and we're going to do exactly the same thing again and again. So,
Professor, I have another question.
please.
Because for number 27, you didn't do it, but for 31, you divided the entire equation by 2. Why did you do that?
Because I had not clean x squared and y squared, because I had 2 with them. In the previous exercise, which is, you say 27, we had just x squared and y squared. But there we had 2 with them, and that bothered me badly, because my goal is not to have anything with those squares, so I divided. So same thing you will probably do here, like if you do 33, you see 2 with x squared, so get rid of this 2, divide by 2, and same will kill that 2 with y squared. But in exercise like 28, there's just clean x squared and y squared, so I don't need to divide by 2, because they already prepared to complete square. Like in 24, you have 3 with x and y, so you will divide by 3. So maybe next time I'll do one more of that type. I don't think I should do it again. It'd be too much for today. But I'm glad that you are paying attention, because all this comparison, that's actually where the ideas are coming from. So you want to have clean x squared and clean y squared, and then you'll be able to complete the square to get your new goal. So we will be working with formulas in this class. So, well, I guess that's the way to go. But no worries. When I'll be giving you the tests, I will always tell you what to expect on the test. I usually don't give many problems. I give 2 problems on the test. 2. Not 10, not parts A, B, C. Just one exercise, and probably one exercise of this kind will be on the test, but not with circles, but with something that comes later. So this is something very, very popular. So little by little we'll be practicing. And again, for the test, I will give my students the whole day so they can take, so you guys can take your time, not to hurry. So in terms of time, you will be just fine. But again, I recommend you to redo, maybe do problem 31 or 27 again, and that be your homework that you will eventually email to me and get a full credit. Okay. So I'm glad that you are working on this. I'm gonna give you a break. I'm gonna let you relax. No quiz today. I know it's too much. It's the first day of class. All of a sudden, such a big thing falls on your head. And if you did not see this completing of squares before, well, look at it again, and we will do it together. Okay. So I'm going to stop the recording and see if you have any other questions. Please ask.
Professor,